Hello, everybody. Welcome to the Lights on Data show. Today, we're going to tackle the topic of best practices in data movement.
And our guest today is Michel Tricot, or Mike as he calls himself, and he's the co-founder and CEO of Airbyte, which started in 2020 as an open source data integration platform with a vision of commoditizing data integration pipelines across all industries and organizations. He has been working in the data engineering for many, many years now, and previously was head of integrations and director of engineering at LiverAmp. Welcome, Michel.
Hi, thank you, George. Thank you, Diana. Thank you for having me.
We're very happy to have you. And as always, we just wanted to ask a more personal question. Could you share a hobby of yours with us?
Yeah, of course. I have a lot of like things happening every day in my life, and so my hobbies are very calm. And one that I really like is being in my backyard and smoking some meat. It's a very meditative activity.
Oh, yeah.
Yeah. So sometimes I have my kids would join me on that activity, but yeah, it's a very peaceful one where you can just be with yourself, with your thought, and no interaction with no interruptions. Yeah.
Very nice. Well, I'm jealous for your family. I love smoking it as well, but I know it also takes hours of preparation, right? So, which some would say would resemble sometimes moving data, transferring data from one system to another. It can take a lot to set up and a lot of heartaches, but it's worth the effort once it's done properly, right?
Exactly. That's exactly.
Yeah.
I could not have said it a better way.
So, well, as we know, data integration, data movement, they're really critical for the modern data-driven organization. What would you say are some of the common challenges that you've observed in ETL processes?
Yeah, I think the main process, and it's funny, like this morning I was just reading one of our Slack chat, and there was this XKCD comics, and I think it outlined exactly the pain of doing ETL, doing ELT, and doing data movement the right way, which is organically these systems are built manually, meaning that it's just I don't know, like a massive amount of small little Python scripts, small scripts that are just running around, like being executed by a cron, being executed by another system, and you just have like this patchwork of solutions. And I think that's the real pain. It's just it has a lot of complexity and a lot of custom work. And in the end, it's just you put the finger into it and you get pulled apart by the engine. So that's really what we see as a big pain today.
And so many, like you said, they are evolving organically as well, and there's so many that could be doing the same thing and maybe not in the most efficient way as well, done by different people for different purposes. So can you then share some best practices to address this challenge effectively?
Yeah. So I think the first piece is, especially in today's world, is people want to understand where data is actually going. So this is the first place. And that's why we keep talking about the centralization of it. And centralization doesn't mean that there is only one system. It can be multiple systems, but you have one system that gives you the visibility on it. And this is really what we see when we talk about data movement is you need two main things. You need to have the control, meaning you need to know where things is going. You need to have the ability to interact with it in an easy way, maybe not always an engineer. And the second one is you need to have access to data. So you need to be thinking about the needs that you have today, which is I have data on Salesforce, I have data on my Postgres database, but tomorrow maybe there is Salesforce V100 that exists. Like, how do you make sure that your system will be able to adapt to the future need of your company, of your team, of your business? And I think that's the piece that needs to be thought about very carefully. Is just how do you think about the future access and the future silos that your organization is going to create so that you don't end up creating yet another parallel system with custom scripts, custom cron, custom everything. So
right.
To me, that's really how I see that.
Yeah. Which is not always easy, and to kind of anticipate some of the changes that would happen in the target systems as well, and to try and accommodate it as much as possible, thinking ahead, but also, of course, having the tools in place to allow you to do all these things, to be a bit more nimble, a bit more efficient in how you're designing your ETLs.
Yeah, yeah. I think you put you said something interesting, which is the everything that is related to data movement is something where you only control one thing. You only control the pipe. That's all. The source you don't control, the destination you don't control, and generally the source, it's not even something that runs within your organization. So you have absolutely no control. Like if it's an API, you don't know if they're going to change the API, the data model, or anything like that. So you need to make sure that the pipes that you're building have resiliency as a first-class citizen. And that's really what is important. Otherwise, your team will continuously be fixing issues, adapting to how the source is working. And yeah, like this resiliency part is important. Otherwise, you start spending tons and tons of people's time on maintaining these pipes.
Mm-hmm, mm-hmm. And then, well, let's also talk about the other way around, flipping it with the reverse ETL.
Yeah, so could you explain what reverse ETL is and maybe share some examples of how it can benefit businesses?
Yeah, I think the first time we talked, I don't know if I mentioned to you, but I'm one of these person who just dislike the fact that we call it reverse ETL because the use case, like when you talk about reverse ETL, you put it at the data layer, meaning it is something that data engineers do, and it serves the purpose of a data engineer. Reverse ETL is about like the business user. It's about the marketing team. It's about the sales team. It's about how do they become more efficient? It's what we call the operational use case of moving data around. And reverse ETL, if we take an example, it could be marketing. It's just, okay, you're getting product interactions, events that are coming into your data warehouse. And suddenly you say, okay, I want to create a little email campaign for whenever someone does these 5 different actions, I want to trigger an email to be sent. And that's what reverse ETL means. It's one way. It's the automation of an action based on data that lives in your warehouse. And that's why I'm saying that it's not really a data. It's not just like purely data. It's really about automation. It's about marketing team. So that's people call it the reverse, but it's more triggering an action somewhere or using data for an operational use case.
Right. And Kate is, asking is reverse ETL LTE? You would think, but not really.
No, not really. I mean, I think so. We actually published a blog post that we call it. We make it more part of publish, but in the end, reverse ETL. That's why I'm not a big fan of the word. It is still ETL or ELT because ETL means you extract data from a system. In reverse ETL, you do the same thing, except that instead of extracting from an API, you extract from a warehouse. Then you transform it, and then you load it in an external API that can be like customer.io or like HubSpot or anything like that. So it's just your chaining ETL or ELT processes together.
Thank you so much for that explanation. Yeah. Well, let's also talk about something that I think it's also could be contentious, and that's batch processing or stream processing and the pipelines. So, can we just talk maybe about how they differ, first of all, and then the different scenarios where you might use one or the other in moving that data?
Yeah. So I think here it's really about identifying the 3 ways, or let's say 2.5 ways companies are using data. The first one is what I call insights, or analytics, which is basically your ability to understand the past to make decisions for the future. And the second one is more the operational use case, and reverse ETL is a part of it. The 0.5 is more like the AI. So this is something that is newer, but let's focus on the first 2. So when you do analytics, when you are looking for insights, in general, you have a human being that is looking at the data, that is looking at this dashboard. Having real time that juries like streaming gives you It's nobody can make real-time decision by just looking every single second at the dashboard. So I would say that's a place where streaming or real-time can be a little bit overkill. Now, on the operational use case, that's very different, because here you're generally going to get a continuous flow of information and this data needs to be put into operational system. So the moment someone, for example, signs up on a website, you want that data to be available to your sales team in case that, or your support team. So this is where streaming becomes more important. Now, streaming is also necessary whenever you have data that is what I call ephemeral data, meaning that it's data that you're just collecting as actions are happening, but it's more like a collecting tactic than a processing tactic. So in the end, it just depends on the use case, but doing an analytic system on streaming or real-time data is generally very overkill, but there is also an in-between between just full real-time / streaming and full batch, which is what we call micro batches, which is the ability to get new data every 5 minutes or every 10 minutes. And most of the time that is enough for most companies to work with. So I'm not trying to, this is not a place where I'm trying to create any kind of contention or anything. It's really about use cases and not also over engineering things, because a streaming system also is harder to maintain, because the moment it goes down, in general, you're losing all that data, because all that ephemeral data can go nowhere.
Right. So maybe an application for needing the streaming one would be, let's say, sometimes working with sensor data, or even like an e-commerce site like Amazon, to try and analyze that data as much close to real time as possible. Okay.
Yeah, but this one is really what I call operational. It's not about analytics. It is operational. So for operational data, yes, having something that can be closer to real time will depend on your business. Like how quickly, like typically if you're Google, let's say you're Tesla, and you're getting all this sensor data from your cars. You're going to use this data for maybe two things. One is, I want to make my maps better. Well, this is going to be a batch process. Like you're not going to upgrade the map, like the road and the structure of the roads every single second. Now, maybe you want to get traffic information. And this one is more streaming related, because you want to make an action directly when the data arrives. So I think that's also like the type of use cases to think about when thinking about streaming versus batch.
Right. Thank you.
I think we have a very interesting question from Ravi Saraswat. He asked, what should be the best practices for having a golden record for data movement? Thanks.
A golden
record. I think moving that data, it's easier when you have transactional data, but then when you're looking at the master data, that can be a little bit more tricky when you have multiple systems that you need to move that record against.
Yeah, I actually think that the moment data can flow freely, it weakens a little bit the concept of like source of truth or golden data, because suddenly your data is not stuck in a system. Like, you can look and the data, you can rebuild in a way this golden or like this source of truth of data in a lot of different systems, because your data has now become portable across systems. Now, I'm not saying that it's perfect, but in general, when you start working with data and you start introducing like data movement, storage, and data warehouses, your data warehouses in a way becomes your source of truth for your data. So you are bringing data from other source of truth, like can be Salesforce, can be a Postgres database, and you bring it into your data warehouse, and suddenly, or your lakehouse, and that becomes your hub of all the data that you own as a company.
Yeah, makes sense. Thank you so much. We also have another question here from Manjunatha. Glad that you could join us today. How would you address the latency requirements in data movement for reverse ETL for operational workflows via analytical insights? That's a heavy one.
Yeah, so let me interpret the question. So how do you address the latency requirements in data movement for reverse ETL? Okay, so I'm not sure I fully get the via analytical insights, but the latency requirement for reverse ETL, I think that's where it really depends on your business and your use case. And that's why I don't like to put reverse ETL in the data space, because it is not a data requirement. It is not a data team requirement. It's a business requirement. So if your marketing team tells you that, or your support team tells you that the moment someone signs up on my web app, I need to know and have all this information in my Zendesk, in my support application, because we've realized that if we interact with that person within the 5 first minutes they are on the web app, then that's your business use case. And then you need to think about that latency and you need to reuse it as much as possible. But still, 5 minutes. So it's not really real time. You have 5 minutes delay to get it there. So that's where micro batches become very useful, because it's easier to manage and you still get a pretty decent latency. So I don't know if that answered the question, but
thank you. Okay, well, let's reverse, and I'll talk about reverse ETL. Let's look ahead a little bit. Let's talk about the future. What emerging trends or technologies do you see shaping the future of data movement and data integration?
Yeah, for me, there are technologies, but there is also ways of thinking about data. I think right now we have hit a level of maturity on how we deal with data. Let me do a parallel actually with how computers came to world. Like initially for like 20 years, it was just experts. Like before let's say the 90s or the 80s, like experts, only very, very specific people could write a software, could manage a CPU and things like that. And then it became more mainstream. And I think what happened in the 2000 and 2010s was data was very, very complex. Like Hadoop is a complex system. Only an engineer can work with it. Spark is a complex system. But bit by bit, we started to build abstraction layers on top of it. And data warehouses, like the modern ones we have today, are a very good example of the maturity we've hit, which is now even a less technical person can do something with data. And I think we're at a point where we are defining what are the fundamentals of this infrastructure. The same way we've defined that a CPU is a standard for building a computer, a hard drive is a standard, and network is a standard. And same thing is happening in the data world, which is you have data movement, you have storage, and you have compute or processing. So that can be a warehouse, or that can be a Spark, or whatever you want. I think it's more like the mentality of people approaching these problems, where they go to fundamentals rather than looking at tools. And that gives them like more visibility on how these systems are going to evolve in the future, where you're not reinventing CPU every single day. Same way, you're not going to reinvent the way you process data every single day, whereas before it was just every year you have a new system that can process data for you. And now in terms of technology, of course, AI is a big deal, because now you have access to data that was not available before without spending a lot of money and a lot of humans' time on it, which is you can work with unstructured data. Like that's what LLM can do. They can extract signals and they can structure unstructured data. And I think this is absolutely invaluable for the world. Like
definitely.
90%, maybe 95% of the data is unstructured data. And suddenly you're just opening up the world to how do you process this 95% of the data. And it doesn't mean that it was not done before, it was done at a very, very high cost. Now it's cheap. And I think that's going to be a big, big driver on how data moves, where it's going, how it's processed.
Yeah, it's democratizing even further.
Yeah. So then 2 questions that come to my mind. So first, what is Airbyte's role in all of this? And then secondly, a question that Kate Strachny asked. Can you talk about the impact of your recent partnership with Victara?
Yeah. So
first of all, Airbyte.
And Victara is a Gen AI company, right? They're allowing other organizations to create their ChatGPT-like services?
Yeah. So I'm an engineer originally, and I always look at building systems in layers. And the deeper you go, the lower level you are. And yeah, lower level, like physical infrastructure, CPU, GPUs, memory, storage, etc. Then you go a level higher, and you have on that one side you have applications that just rely on this infrastructure, but you also have data, and data is a part of this infrastructure. So same thing, like how do you move data, how do you store data, how do you process data? Now on top of that, you have another layer, which is AI, like or any kind of like model or application or that relate to AI. And this is also going to become, we're also going to identify what the ideal infrastructure should look like for AI. Right now, it's still a big blob of a lot of tools and things, but it builds up on top of data. If you don't have data, you cannot train model. You don't have data to put to your model. So that is the role that we're playing with Airbyte. Is we're just this layer under AI that brings that data into AI system, whether it's, I don't know, for RAG type of systems where you put data into vector stores, or when it's just bringing data onto, I don't know, Databricks or Snowflake or whatever, any application that can then train a model on top of that data. So that's the role we play. Now, in terms of vector, for us, it's really about integrating with as many destination as we can. Like, our company mission is just to make data actionable and available to users. So making it actionable means that it's presented in a form that people can do something with, and available is about putting this data in a place where people interact with every single day. And integrating with Vector is one of these. It's like you have people who rely on data. How do we bring data into that system? So that's really how we see the world with this integration. And that's really what we're here for, is moving data around. We want to make sure that if you need data in place X, data gets in place X.
Love it. So yeah, so you talked about people having to rely on that data. So let's talk about that trust. Let's talk about the data contracts and the role that they play in data integration. Can you just elaborate a little bit what data contracts are to start? Why they're important and how organizations can establish and enforce them effectively.
Yeah. So here I'm going to take my my software engineer hat to talk about that. It's before you had, it's basically for me it's exactly the same thing as an interface in software development, meaning that it doesn't matter what happened behind the scene, but everything that is external facing, there are rules that govern how that data should be looked at, should be verified, and should be understood. And that's what a data contract is. For me, you could call that data interface, same thing. It's just a matter of what are you promising to your users without telling them all the details that are happening behind the scene. So that's what data contract is for me. And the reason why it's important to think about data contracts, data interfaces, is that it's not a small team of 5 people that are working on data anymore. It's a whole organization, because the technology is easier to use. So the moment you start expanding your user base of who is using your data, then it becomes very, very hard to have that, I don't know, organic knowledge in your head or tribal knowledge in your head. You need to have something that where all this information is codified and people know they can rely on it and it's verified. So that's where I see the value. It's about scaling usage of data within an organization.
And if something changes at the source, let's say, then those users would be notified. And
exactly.
They would be aware of the changes to be able to adapt to them.
Yeah, we have a part of data contract within Airbyte. We call it more like schema evolution. Like data contracts looks at it at different level. You have like the semantic meaning. You also have the more like the typing or the structure of the data. We don't look so much at the semantic layer. but we look at the rest, which is there a new column that's being added? Is there one that's being removed? Is there a type that is changing? And we try to catch that ahead of time, like before the data lands into the destination. So our users know that something is happening and they can decide what they want to do. Because the worst thing is you send the wrong data, you send data and you don't know it's changed, the meaning has changed, that the type has changed, and suddenly you end up with corrupted data at the destination. So we try to prevent that.
Saif is wondering, how do you recommend a company implements data contracts? Actually, who even implements the data contract? Is it the data engineering team? Or is it part of data governance? Or
yeah, I would put that more in. For me, it should be the producer of the data that does that, but now you can say that the producer can be at multiple level. It can be the person that is at the source level, or it can be the person that is moving that data, or it can be the person that is publishing, like, I don't know, production ready tables in their warehouses. So I think it can happen at different levels. And here again, it's a matter of how your organization is structured, or it's a mix of all three. So I don't think there is a specific individual that's responsible for it or role.
I could see that, becoming even more challenging when you have a data product that includes data from multiple sources, where you have different data producers as well. And yeah. So it depends case by case.
Yeah, exactly. You're pulling data from Postgres. Maybe software engineers or IT is responsible for data contracts, or maybe it's the person who is plugging into Postgres that is defining what a data contract is for that table. So it really depends.
Right. So before you mentioned that you're trying to simplify this data movement, and for that you need to have all these different connectors in place. So would you say that it's also now catering to data scientists, and to make that even more accessible, to be able to integrate into their notebooks and so forth and so on?
Yeah. So to me, there was really when we think about data, there's two use cases here. Is for in that particular, like, one is critical pipeline and production workload, meaning that you have established an engine to calculate analytics, to do your operational use case, but you also have the experimentation and the research piece of it. And that's generally what happens in Notebook, where you have someone who is trying to understand what that data is and doing all these experiments and discovery. And that's a place where these practitioners, they need that data as well. And they want to focus on extracting new insights or new information from that data. They just don't care about how do I connect to my, I don't know, Postgres database. This is not something this persona or this user wants to do. They want to have the data available. And so that's also when we're looking at Airbyte, is we've built this great collection of data connectors, but we've been extremely focused on these operational production ready use cases. Now, as we go and start to work more with AI teams, which have more like a more notebook mindset, we're looking at how do we make these connectors available directly into Notebook without having to install the whole machinery of Airbyte. So that is something that we keep in mind, because we just want to make data available where people need it. So fits with our mission as a company.
Love it.
Yeah.
And it's a new product. It's not yet live. Right now we're experimenting it internally, but the ability to bring data and to bring Airbyte connectors directly into Notebook is something we're going to be talking quite a bit in the next few months.
Yeah, you mentioned your mission, which is to give your infrastructure superpowers to collect and move data seamlessly, whatever the tools you use, all by anticipating the changes to come and respecting your users' rights for data security. Love it. So that being said, can you share some examples or use cases where Airbyte has successfully helped organizations achieve this mission?
Yeah, absolutely. I think recently there was an article from Datadog where internally, they've been working on how do I look at, I don't know, my ATS, like doing analysis on applicants within within my system. I mean, they're hiring a lot of amazing people, and like, how do I get information about my ATS system? And so what they did is they installed Airbyte internally. They tweaked one of the connectors, and one thing that was very important as well for them was the privacy of that data. And with Airbyte, they were able to just very easily get that data, and before it gets persisted, trim out data that could be like PII or anything like that. And that's really the power that you get is now you have a centralized view of where your data is moving. And you can also add these layers of security and privacy on top of your data. And now how do you bring, and after that, just, okay, you've addressed one use case. Now what are other use cases within your companies? And then you start bringing more and more systems together. Mm-hmm. So that would be an example. Like we're what? About 140,000 deployments of Airbyte. So,
wow.
Yeah, another one that was, and this one was very interesting because it was an operational use case we never thought about, was someone developed a Redis destination, and their goal was, and that was a company in Australia. And what they wanted to do is every day they wanted to re-hit their cache, basically. So they would just take the database, replicate it into Redis, and boom, call it a day. And so they had that process of rewarming their cache using Airbyte. And that's not, I would never have thought about that use case. Never.
I like it that you already, had a solution for a use case that you haven't even thought about. And there you go. That really talks about the versatility of Airbyte as well.
Yeah. And that's why we are approaching data movement as it is infrastructure. When people build CPUs, they don't think about what's going to be running on it. They just give you the ability to run something. And that's what we're doing with Airbyte, is we give you the ability to move data. Now, what you do with it, it's up to you.
So then for organizations looking to improve their data integration practices, what advice, what recommendations would you offer, especially in terms of choosing the right tools and strategies to really meet their needs?
Yeah. In terms of tools, I never really have an advice, because in the end, tools will have pros and cons. For me, it's always about being first principle thinker, which is what are the pillars that you need to have whenever you think about data. Because once you have this pillar right, it becomes easier to layer things on top of it, to unlayer things, to relayer. And for me, it's always think about how you make your data portable, how you store your data, and how you process it. If you have these three, and first it will make like every kind of internal communication much, much easier about how the system is designed, how the system can be used. But it will also make it so that, well, if I'm moving data this way, let's see now how I can layer in more governance on top of it. And then you start building these things, but you need to have these three fundamentals. That's what makes your system future-proof.
Right.
But in terms of tool, of course, I want people to use Airbyte. But
so, talking about that, you're basically creating the future as we speak. And we wanted to ask now, as we're coming to an end, what excites you most about the future of data integration, and how do you envision Airbyte's role in shaping its future?
Yeah. I've always had that. I'm a collector. I like to store things ever since I'm a kid. And
George does too.
While I'm smoking meats. No, but I really like to collect things, and I really like to see what can I do with these things. And for me to realize that now there is this whole part of the data that was not being used, at least not by 99.9% of the companies, which is unstructured data, that is now becoming available to companies. That's I want to be part of that revolution because to me, data is power. It's like it's knowledge. Like, and the moment you know how to apply that knowledge, I think you become smarter. You become better at everything. So that's where I see that. It's like, in a way, like 95% of our knowledge or automated knowledge is stuck, and we're unleashing it right now. So I cannot wait to see what that's gonna give.
Love it. The future is bright.
Exactly.
And, yeah,
it's all ours.
Right.
It's all ours if you have access to the right data, and we can
Exactly.
have those data integrations seamlessly and easy to set up. You know what? I put this graphic yesterday. It was sort of this pie chart describing the time segments that a data scientist is spending on. And, you know, there were like some fun jokes in there that, you know, they're spending a lot on data quality and not as much on the statistics and data visualizations and data storytelling and so on. Anyways, and there were quite a few comments that were mentioning, well, you know what, you forgot the piece of pie chart where data scientists are just waiting for their data to happen. They're waiting for that data integration piece to be done with. So we definitely need more solutions that are more efficient, more robust, and hopefully self-serve as well, because as you said, the user base is expanding so much in a company that you can't put it all in the hands of a handful of people as part of IT.
Yeah. Actually, to that, I remember like in 2015, 2016, the role of data scientists became extremely popular. And it's because Google, Facebook, like this 0.0001% of company had figured out how to best leverage data. But what people did not see when they start thinking about data scientists, etc., is that there is a massive piece of infrastructure that they had to build to enable data scientists.
Right.
And at some point, like you had all these data scientists being hired, and what they had to do was not doing data science. It was about building data infrastructure. And I think that's also, we're living through that, which is now people have realized that to get your data scientist the happiest is you need to have that layer that is being built and that is maintained not by them, but by another team that enables them. And that's really where we are today. We've realized that, yeah, all these other 0.001% of companies have built that. Now let's just bundle it and make it available to companies so that they can be as powerful as this 0.001% of companies.
Love it. Well, and if you want to be, you know, part of that 0.11% and actually you want to elevate your data integration capabilities, you want to enable those, check out airbyte.com. Also check out their GitHub repository and have a blast. You guys also offer a free trial there that I recommend everybody to take on and just learn a little bit more about what Airbyte can do. Yeah. Well, thank you so much, everybody.
Thank you very much, everyone, for the questions. Thank you so much, Michel, for being here and for sharing all these insights and for everything that you do and for revolutionizing the data field. I wish everyone a happy weekend, and we'll see you next week.